Okay, so problem number 1 from your quiz. If you take a look at it, you know that in order to be able to solve this equation, it needs to be set equal to 0. And so I personally, in order to get it to be 0, a lot of people have been doing this, where they subtract 3a to the second from both sides to move that 3a to the second over. And there's nothing wrong with that whatsoever. I, however, am going to go ahead and do minus 7 on both sides because that'll move the 7 over to the other side. And then I'm going to add 20a to both sides as well, because I prefer to have everything on that side because it deals with fewer negatives. And remember that because this is an a to the second and that's just a regular old a, you can't combine them because they're not like terms. One has a variable of 2 and the other doesn't. So we need to leave them all three written out, not combined. So we've got 3a to the second plus 20a minus 7 is equal to 0. And the reason I chose to write it in that order is that, if you'll recall, we like this side to be in standard form with the exponent of 2 first, then that 1, and then finally the number by itself. So now we're going to kind of ignore this side for a minute, and we're just going to deal with the left-hand side, and we're going to do it by factoring. And so if I take a look, I know that this isn't special because neither of those is a perfect square. There's no greatest common factor. It is, however, a quadratic trinomial. And it would be nice if a were equal to 1, because then that would be a lot easier to factor. But unfortunately, it's not. So that means we need to do the AC method. So we've got a times c. So in this case, that'll be 3 times negative 7, which is, of course, going to be negative 21. So we have to figure out what can we multiply to get negative 21 that we can add to get b, which in this case would be 20. So to get negative 21, we could multiply a positive 21 and a negative 1, because positive 21 times negative 1 would give you negative 21. Also, if you add those two numbers together, so 21 minus 1, that also gives you that 20. So the whole point of doing that was that now we're going to take the original problem. I'm going to forget about the equal 0 for a second, even though I know it's already there. And I'm going to break up that middle term into 21a minus a. So that leaves me with 3a to the second plus 21a minus 7. And because I've now have 4 terms, that means I can factor by grouping. So I'm going to group these two together, and I'm going to factor out a 3a. So if I factor out that 3a, that will leave me with an a plus 7 left over. And if I look here, I can see that I can factor out a negative 1. And if I factor out a negative 1, I have an a plus 7. So I know I'm on the right track because these two binomials end up being the same. So I'm going to factor that out, a plus 7, and then the 3a minus 1 goes into the parentheses. So now I've got it factored. So now I need to deal with that equals to 0 component. So either this has to be equal to 0 or this has to be equal to 0, because the way multiplication works, obviously 0 times anything is going to give you 0. So I've got a plus 7 is equal to 0. So I subtract 7 from both sides. That leaves me with one solution, which is a is equal to negative 7. And then I also need to deal with this binomial. So 3a minus 1 is equal to 0. And I solve that by adding 1 to both sides. That leaves me with 3a is equal to 1. Divide both sides by 3. A is equal to 1/3. So my two solutions are -7 and +1/3. So it would look, we know I can't draw those braces. It would look a little something like that.